All right, so for the tangent graph, I'm kind of just going to start filling in some points, like 0, the usual, pi over 2, pi, 3 pi over 2, 2 pi. And then we're going to figure out where the tangent graph is for all of these and see if this helps us, okay? So what are the coordinates of the unit circle at an angle of 0? So at 0, we're at 1, comma 0, right? And how do you find tangent? Sine over cosine, or y over x. Well, what's 0 over 1? So at 0, the tangent graph is going to have a value of 0. Is that clear? Okay. Let's go to pi over 2. What are the coordinates at pi over 2 for the unit circle? 0, 1. Tangent is 1 over 0, which is undefined. We saw those on Friday. What are all the undefineds going to become? Asymptotes. So I'm going to put an asymptote at pi over 2. Now for pi, now it's -1, 0. But we still do y over x to figure out tangent. And 0 over anything is 0. Well, I should say 0 over -1 is 0. 3 pi over 2, we're at 0, -1 on the unit circle. Tangent will be undefined. So we get an asymptote. 2 pi is 1, 0 again. So now it's going to give us another 0 value. I don't really have any other information except that we have asymptotes and then this point in the middle, right? So here's what we're going to do, because we want to get a little more specific, right? Let's go pi over 4. So I'm going to put pi over 4 on the graph. Yes, the coordinates are root 2 over 2, root 2 over 2. And how do you find tangent here? Y over x, we get 1. So I'm going to go to 1. So at pi over 4, the tangent graph is actually at 1. And now let's go backwards to negative pi over 4. At negative pi over 4, it'd be the same x and y values. The only difference is that y is negative, right? So what's tangent going to be there? -1. So at pi over 4, we're at -1. And I added an extra point back here at negative pi over 2 to just kind of see what's going to go on there. At negative pi over 2, the coordinates are 0, -1. Tangent there is undefined. And now I think we're starting to see a better picture. Where else have we seen this, where you have two asymptotes and you got these points here? Yeah, so, I mean, the trig's going to work out, but you're going to basically see what looks like a cubic graph. Okay? In fact, that's exactly what's going to happen between all the asymptotes. Okay?
If it happens for one, does that mean it happens for all?
Yes. So now here's the next question. The length of one period. How long does it take for this graph to repeat?
Pi.
Very good. It's pi, not 2 pi. Okay. The amplitude, there is none. X-intercepts, hopefully we're getting better at doing this now. Pick one. So 0. What's the pattern?
Pi.
They go up by pi. So plus pi k, where k is any integer. The y-intercept for the tangent graph is 0, since we're at the origin. The domain is not all real numbers because we have asymptotes at a whole bunch of values, right? So let's say the domain is everything except the value of the asymptotes. And what would those be? So let's pick one. Pi over 2. And then how far apart are all the... There you go.
How do you know it's pi?
Because from pi over 2 to 3 pi over 2 is 2 pi over 2. 2 pi over 2 is just 1 pi.
Wait, for x intercept, we can say, like, for example, pi over 4 plus pi k.
Pi over 4 is not an x-intercept.
For example, pi plus
Yes,
k.
pi plus pi k is fine.
Pi over 2.
Yes. Range. Yes. And the asymptote, well, it's just the values that we don't want for the domain. So the asymptotes will be exactly what we wrote above, except now they do equal. And we're not going to graph two periods of tangent because we already did up here. Okay, are there any questions on the tangent graph? Okay, so let me recap what you should know so far. A lot of times when we're graphing these graphs, I ask you, well, how does sine start? How does cosine start, right? Let's review. Where does sine usually start? At 0, and then we know what to do after that, right? Where does cosine start? At 1, and we certainly know what to do after that, right? I'm going to ask you to memorize the same thing with tangent. So with tangent, the tangent graph, it's kind of weird because it's actually in the middle of a phase. Do you guys see what I'm talking about? But I want you to memorize this point that the origin is in the middle of the tangent graph. Does that make sense? So when we actually graph one period, what I expect you to do is say, let's move left or right, whatever, and then our starting point is going to be this middle point. And then what we're going to do is go 2 units to the right, put down an asymptote, 2 units to the left, put down an asymptote, so that basically we have this picture for one period. And we'll do an example of that in a minute. Okay, but just remember, sine starts with 0, cosine starts with 1, tangent is in the middle of its phase at 0 when we start graphing it. Okay? All right, let's go to cotangent. And we'll do the exact same thing for the cotangent graph. We'll start with pi over 2. We'll go in between at pi over 4.
Do you record this?
It is being recorded, yeah.
Did you record the sine and cosine?
Yeah. Now, I'm just going to cut to the chase for cotangent, but we're going to use pi over 4 as our scale again. The period is going to be pi. If tangent has a period of pi, since cotangent is just the reciprocal, that's not going to change the period at all, okay? But let's just kind of go with it. At 0, what are the coordinates for the unit circle? 1, comma 0. Cotangent is x divided by y, which is undefined. So you know how tangent started with a point in the middle? Cotangent starts with an asymptote. Okay? Now, at pi over 4, coordinates are root 2 over 2, root 2 over 2. Tangent is cotangent is x over y. So that's a value of 1. So I'm going to put a point at 1 where pi over 4 is located. Pi over 2 is at 0, comma 1. Cotangent is x divided by y, so that's 0. At 3 pi over 4, we're in quadrant 2, so that's negative root 2 over 2, root 2 over 2. x divided by y is cotangent, so that's a value of -1. And let's finish with pi. Pi is -1, 0. Cotangent is undefined. And guess what happens after that? It just repeats. Okay? So here is the cotangent graph. It's also like a cubic, but it's the reverse shape of tangent, and it starts a little differently. Okay? I'll let you guys fill out the details on your own. So right here, do this on your own here in a few minutes. Just like we did with the tangent graph. What I want to do is actually do one cotangent graph and then one tangent graph so that you can see how those work. So if you want in your notebooks, or even if you have some space where you can squeeze them in, I'll do two separate examples. Let's say we have y equals 2 tangent of pi x minus pi. All right, what do we do when we have the graph? What do we find? Period. Okay, so here's where things change. Everything else is the same, though. The period for sine, cosine, cosecant, and secant were always what? 2 pi, and then we divided by a b if there was a b value, right? Well, the tangent and cotangent graphs are a little different because the period is pi. So instead of doing pi, I just gave you an answer. Instead of doing 2 pi over b, to calculate the new period, we always do pi divided by b here. Okay?
It's only for tangent.
It's only for tangent and cotangent. Yep. So in this case, the period would be pi over pi, which is 1. My scale that I'm going to use, you always do the same thing, which is take the period, divide it by 4. There is a phase shift. Phase shift is still c over b. So that's pi over pi, which is 1 to the right. Because we're subtracting. And we don't have an amplitude, but this 2, you know those 1s that we graphed? They're now going to be 2s. That's the only thing that changes. Okay? So let's get started. So here's what I would recommend doing. Always start with the phase shift. So this tells me that I'm going to start my tangent graph at 1 unit. And what does tangent look like here at our starting position? It's at 0. Very good. It's in the middle of its thing, right? In the middle of its phase. If I go 2 units out, I get an asymptote. And if I go 2 units back, there's going to be another asymptote. I should probably label the scale first just to see where I'm at. The scale is a quarter, right? So here would be 1.5, or I'm sorry, 1.25, and then 1.5. And if I go left, 0.75, and I probably should have thought about the scale before I put it on here. This is going to be not exactly perfect, but this is 0.50. And at 0.50, we have another asymptote. Okay, so you start with the phase shift. Tangent's always in the middle of its cycle when we move. We go 2 units to the right, 2 units to the left. Those are the asymptotes of the graph. And now tangent looks like a regular cubic, right? So when I go 1 unit to the right, instead of going 1 unit up, I'm going to go 2 units up, since we have a 2 in front of the graph. And we do the same thing when we go to the left a unit. And there's one copy of tangent graph.
So you just need to remember how it looks like, and that's it.
Yes, that's how you do all of these. You remember what it looks like, and then you move it, and then just that's it. Change the axis, right? You got to change the axis a little bit, but that's good. All right, let's try a cotangent example, and then we'll be done. Let's say we have y equals negative cotangent of two x. Okay. What's the period going to be? So pi divided by b is pi over 2. What scale should we use then? If we're taking pi over 2 and cutting it into 4 pieces, that's the same as multiplying by a quarter. So pi over 8. There is no phase shift, so that's really all we need. Well, it makes the shape look like tangent.
Yeah.
It doesn't mean we're going to start at 0, but yes, exactly. So Patrick pointed something out. This negative sign, all it's going to do is flip the way the cubic looks. So it's going to look more like it did when it was tangent. Okay? There's no phase shift, so let's have you guys remind me. What do I do to start my graph for cotangent? Asymptote. Okay, so there's an asymptote right away at x equals 0. Now I'm going to count 1, 2, 3, 4. I'm going to label my axis using my scale, which is pi over 8. So pi over 8. 2 pi over 8 is pi over 4. 3 pi over 8. And then 4 pi over 8, which is pi over 2. And we end with an asymptote. What's in the middle? A point on 0. And cotangent was the one that was backwards, right? However, we have the negative in front, right? So that's going to actually make it look like this.
Why do you
How the heck do you get the asymptotes?
Well, the regular cotangent graph started with an asymptote at 0. Since there's no phase shift here, then that's going to be the same exact story with this one. And then the next asymptote is just going to be a period away. So 1, 2, 3, 4, draw an asymptote. Yes?
Yeah.
Using the scale.
What does that mean?
That's what you go up by each x value in the graph.
Oh, well,
Like, you know, on a graph, if your scale for x is 2, you're going to see 0, 2, 4, 6, right? Here, I'm starting at 0 with a scale of pi over 8. So it's 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8.
here your scale is pi over 8. You start with pi over 8, but in
I start with 0 because there's no phase shift.
0. But in tangent, your scale was 1 over 4.
For this one, it was 1 over 4, yeah.
Yeah, but you started at
At 1.
0.5.
I started at 1
Why?
because the phase shift was 1. Remember the tangent graph?
Oh,
Remember, this is the normal tangent graph right here.
oh, it starts at 0.
So when we shift it over 1 unit, it's this middle point that's going to be like your reference point. So then that's why we go 2 units to the right, 2 units to the left. That's where the asymptotes are for cotangent or for tangent. For cotangent, though, this is what the regular cotangent graph looks like, right? So if there's a phase shift, that's the first point is an asymptote, really. Does that make sense? And then you count 1, 2, 3, 4, and then that's the next asymptote. So really it's just a matter of do you memorize or have you memorized this basic shape? Because if you have, then you know what to do on each side. Okay? Other questions on this? Okay. I hope those of you that were texting away and are on iPads and all that stuff actually took good notes and know what the heck's going on, because